Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello, humans.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, Jason Mays. Jason, do you want to introduce yourself? Let people know why you're famous?
Sure, thank you very much. So yes, I'm Jason. I am the developer advocate for TensorFlow.js over at Google, which basically means if you are using machine learning in JavaScript pretty much anywhere out in the wild, there's a good chance that you'll see my face pop up at some point.
Oh, good deal. Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on, it's done with experts from companies like Google, Microsoft, Amazon, and Apple, and it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml, and that'll take you to the right place so you can sign up for the course.
Yes.
More Jason face. That's exactly what we were looking for. Awesome. So I think we talked our way around TensorFlow and TensorFlow.js and a lot of the other technologies that are out there kind of at a high level. Do you want to just kind of give us the high level rundown of what TensorFlow.js is, and then we can kind of run from there?
Yeah. So essentially, TensorFlow.js is an open source machine learning library that you can use that allows you to do machine learning in JavaScript. Now, back in the old days, when TensorFlow first came out, it was just available in Python back in, I think it was like early 2016, around this kind of time frame. And then about 2 years later, TensorFlow.js was born because, well, why not do machine learning in the browser? And there's certain kind of advantages as well by doing it on the client side that you can get, such as privacy, which is just impossible to do if you're sending stuff to the server side. So one of our advantages, if you are running in the web browser at least, is that when you're doing the inference, which is when the machine learning program does the classification essentially on like the raw imagery from your webcam, that webcam data doesn't have to be sent to any third-party server. So that's pretty cool. And especially in the world that we live in these days, where privacy is top of mind, or maybe you're working with like healthcare data or whatever it might be, you can now do that without sending that around all over the place, which is kind of cool. And then there's other bits and pieces you can get from doing it on the client side too, like saving costs and lower latencies, and of course, embracing the reach and scale of the web as well.
Yeah, I just love how I hear all the time, blah, 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 in JavaScript.
Yes.
Yeah, I think it does lend it a bit of ubiquity as well. I mean, I would put forward that machine learning and I'm trying to remember blockchain, those have kind of pushed Python forward, but JavaScript already has a large user base just by virtue of the fact that it's sort of de facto used on the web. And so, it's exciting to see that. I'm somewhat of a JavaScript enthusiast. And so for me, you can do blah, blah, blah in JS gets me excited. So
definitely. And I think ML in JS is still relatively new, even though we've been around for 2 years. I think the wider community is still awakening to the fact that it's possible and what this machine learning thing actually is and what it can do and why you might want to do this in your existing workflows and so on and so forth. So I'm excited to see how people embrace it going forwards.
I think what's really great about it is demo ability of if you can put anything on a website, it's just so beautifully, tangible.
Exactly.
And I'd have to say that since you've kind of like come into frame of beating the drum and helping people like actually build projects with TensorFlow.js, I've seen more and more cool web demos than ever, which is really awesome because, it's a lot more fun than reading a paper.
Right. And I've been amazed at the quality of stuff coming from the community. When I started that Made with TFJ hashtag back in the day, we had a trickle of people starting to use it. And there's some cool things, but mostly they were just using the existing model as is and then being proud that they got it working. And now they're taking it to whole new levels by combining it with existing web technologies, things like WebGL and Free.js, or maybe WebXR and all these other kind of emerging web technologies. And it's very powerful when you combine all these together, you can really innovate and be very creative.
Maybe take a minute for our listeners and let's let them know. So the hashtag is made with TFJS.
That's correct.
And you will guaranteed see Jason there for that. And a lot of really cool things. Yeah. Getting that hashtag started, was it surprisingly easy, hard, or?
Yeah, I just started using it and encouraged others to join in. And I guess the benefit to the end user initially was, okay, if you make something cool and you use it, that allows me to find it. And if I can find it, I might feature you on a blog post or a show and tell or whatever it might be, right? So I think that got the initial kind of community spurred and interested in taking part. And then it kind of organically grew from there.
That leads directly into, you mentioned show and tell, and you've had 2 of those at this as of right now, right?
So far, yes.
Yeah. So I guess walk everybody through why they should go to your next show and tell, what they can expect if they're interested in TensorFlow.js.
So basically, if you have zero experience in machine learning, or maybe you're even new to JavaScript, our show and tell sessions are a great way to get inspired as to what is possible with both of these technologies combined. Essentially, I invite roughly 8 presenters, and they all have 10 minutes each to talk about the latest and greatest thing they've created using TensorFlow.js. And we have a little bit of a to and fro, and they get to demo their work. And it's just generally super exciting. And I kind of cherry pick these 8 presenters each time. And they're basically the most interesting things I've seen since the last show and tell. And that leads to some really awesome creations and a lot of cool discussions. And at the end, I often have a private hangout as well, where I invite all the live listeners to come join a private hangout where if they have any burning questions they want to ask directly, that's not recorded on YouTube Live forever, then that's completely possible. And we can have a bit of one-on-one time, well, one-to-many time, I guess, with any presenters who are left and myself at the end.
Awesome.
Yeah, that's awesome.
So no, machine learning can be scary. I've been down that path. When you're first starting, it's very, well, what is this? And how do I get started? And why do I want to do this stuff in anything? And it's a rabbit hole of things to go down once you start unraveling it. But to get started, you can actually get started in just 2 minutes with no background in programming. We've actually got a website that one of the teams at Google created called Teachable Machine. And it's just a graphical user interface, just a regular website, which allows you to use your webcam as an input device. And you can point it at objects in your room, hit record a few times, and that is its training data. And then you can learn to recognize that object in under 2 minutes of your time with no programming and no machine learning experience. And let me tell you, once you've done that first, you feel like you've got superpowers. You feel, oh my gosh, I can recognize this. And sure, it might not be the perfect machine learning model. Like if I were to recognize a blue deck of cards and then I show it a red deck, it might not realize it's the same thing. And that would require more training data. But even so, just recognizing that blue deck of cards, it opens up so many potential things you could make. So maybe someone was talking to me about recognizing their garage door, if it was open or closed or not. And you could use Teachable Machine to do that. And then they could connect that to their Raspberry Pi and then control the garage door if it was left open after a certain time automatically and other kinds of stuff. So yeah, hardware integration, everything is possible.
That's a good point. I think that for web developers to be excited about something, it has to enter this tinkering domain. And machine learning has always been a bit outside that. And it's gradually moved more and more into this very visual, very tinkering domain, very dopamine rich testing lab environment.
I think there's a whole kind of scale of stuff there now. There's stuff for people who are experts. They can go really nitty gritty down into mathematics of it all and really nerd out. There's also now the more visual editors and visual-based machine learning, which helps for beginners get started essentially, and then they can slowly unravel the rabbit hole as they get more specialist in a certain area or something they need to get extra performance from or whatever it might be that we need to do to go further down that rabbit hole.
That's awesome.
Yeah, the other thing that I see though is that, I've been a web developer for a long time. Plus I'm the guy that my mom calls whenever she has a tech problem, which means I'm an expert.
Oh yes, I know that.
So, and it still feels kind of sci-fi to me, right? And so when I get something going like that, it's not just the adventure of exploration, but it's also just the, hey, I can do this and I can do this in a language I know. because I haven't really
Yeah.
spent a lot of time in Python. And so
Mhm.
the whole project just seems really exciting to me that way.
Totally. And I think it's interesting you said the word sci-fi there. A lot of the demos I create of the recent past, especially, are often inspired by sci-fi movies and things that I've seen. So I don't know if you are aware, but I recently created an invisibility cloak in JavaScript that can remove my body from a live webcam video feed. So then I could potentially join a Zoom or a Google Hangout, and any background people could be removed or something like this. So all this is now possible with just a bit of creativity, and I can have Harry Potter-like effects in the real world almost. So that gets me excited, and often I'm inspired by the sci-fi stuff that I see too.
Yeah, as Jason works through the Deathly Hallows, I am very excited to watch all the exciting kind of aspects. That one that you're talking about, the Harry Potter Invisibility Cloak, is a beautiful demo. And I'll just kind of say it for our listeners. Jason turns on his webcam and then starts walking around the room, and things start moving and without a person in sight, and it's just digitally removing him from frame, which is really, really cool. Do you want to deep dive? That's a great one, because I think the animated GIF is fantastic. And yes, I will say animated GIF for life.
Yeah.
You can't stop me. So, but the animated GIF that you have for when you tweeted that originally was just a great aspect. So I guess from conception to application, can you kind of walk us through as a deep dive into how that started and then getting all the way into the TensorFlow.js?
Sure. So the actual idea came to me when I was dreaming one night. I have one of these random dreams I often have.
I love this.
I love it already.
Every once in a while, I have like a coding dream. I'm literally coding in my dream. It's really bizarre, but I actually essentially solved how I would remove an object from a background in a very trivial way. So all I'm doing is, if you know where certain pixels in the image are of a certain thing, in this case, a human body, I can then know what is a human body and what is not. Now, as the human body starts moving around the scene, I can then tag all the pixels as to when they were a background image or not. And over time, I can eventually build up an image of what the background is. So then I have a complete image that is just the background. Then when the person comes back into frame, if they are in frame, I then pause those pixels on the last known image that had a background pixel there. So that the rest of the pixels can still update. So that's how you see my bed moving in that GIF. I'm still updating the imagery, but not where the person is. So you see when I walk in front of a laptop, the laptop screen actually pauses technically, because that's the last known background image I had for those pixels. And when I move when I move away from the laptop, your laptop's starting to move again. And this is the key thing. Like, if you didn't do that, if it was just take a screenshot of my background and then just replace the video of that technically would work. But then the background would never update, and that kind of removes the magic from the whole experience. That's just an image at that point. Whereas this, the beauty of why this went viral, I believe, is because you see me walking on the bed and the bed deforming. That's where the magic comes in here.
Yeah, this is like every bank heist movie needs to be using this technology instead of looping old video, right? They always catch it. They're always like, "That's not the time. This video's
by a floating head."
Yeah.
You never know.
Yeah, it would be the perfect setup there. That's awesome because, for a demo and experience, sort of like identifying that the person's there. And the person, I guess, is like you're using something like PoseNet to identify yourself.
I'm using body pics, actually, so I can get the body segmentation data back at a pixel level detail rather than just the skeleton of the human, which wouldn't be enough data for me to know where all of that begins and ends, essentially.
Yeah.
And one of the kind of issues I had to work through when I did this, and I actually made this in just one day, which goes to show how easy it is to use some of this machine learning stuff. So BodyPix, for those of you who don't know, is one of the machine learning models that our team has produced and open sourced. So it's wrapped in a super easy to use JavaScript class. So even if you have no machine learning experience, you can just send this class an image, and it will send you a JSON object back with all the pixel data saying if it's got a body or not, essentially. It's just a binary mask of sorts. And with that, you can do it as you wish. Now, most people, when they see something like BodyPix, they're going to be like, oh, well, I can see where the body is. I'm going to highlight it. I'm going to show how many people there are in a scene. And of course, because I know my mind just works differently sometimes, I was like, well, if I've got the body data, maybe I can remove it, which is not this go-to kind of thought path typically. But I like to kind of break things and tinker with things to their limits. So that's the path I took in this case. I'm excited to see what other things can be made with body picks. And we've seen people from the community even, they've managed to use body picks to scan a magazine. So one guy in Paris in France, he can scan a magazine and then he uses Three.js and WebXR to then bring that body from the magazine into his living room so you can then walk up to it and it's all life-size and stuff. And of course, as any good JavaScript developer would do, I saw this and I was like, well, what if I add WebXR to that? So not WebXR, WebRTC to that as well. And thus teleportation was born. And my latest demo allows me to teleport my body anywhere in the world. So you can actually see me in your living room talking to you like I am right now, but visually actually see me standing in front of you and I can teleport myself anywhere in the world. Of course, that was inspired by Star Trek and all this kind of stuff as a reason as to why I wanted to pull this off. But also when I saw WebXR was possible from this other guy's demo, I was like, well, if I can make this real time, then we can do teleportation. So I got excited by that.
Yeah. Help me, Obi-Wan. Awesome. You're our only hope.
I just wanted to teleport some Thai food back here.
Yeah, it's a good time to teleport. So I think that's the only travel that we're getting at the current time while we're recording this.
Yeah. So I'm wondering, since we're talking about some of the capabilities here, let's say that I decide that I want to build something like this. Yeah. How do I get started with TensorFlow.js? And then how do I start pulling in other people's models and building my own models?
Sure. That's a great question. So I would start the opposite to how I would learn to program, where I typically go from the low-level stuff and work my way up. In machine learning land, I'd go from the high-level stuff and work my way down. So first of all, I would just go try something like Teachable Machine. If you just Google that, find the web page, and that allows you to do one of three things. You can recognize an object using your webcam, you can recognize a sound using the microphone, or you can recognize a pose using our PoseNet machine learning model. And these three things are basically accessed via this super easy to use interface that is all completely in the web browser. And you just got to click some buttons and it just magically works. So once you've tried that and you realize that, okay, I can actually make a machine learning model. Your next step is to then take that machine learning model, because you can actually click on export at the top right of this web page, and it'll give you this JSON file that you can download and host on your own web server somewhere. And then you can use that in whatever capacity you wish. So if you can recognize a certain object, then start to think, okay, how can I be creative with that? What can I use that for? So in the garage door example I was talking about earlier, if I can recognize my garage door is open or closed, maybe now I can hook that up to a Raspberry Pi and control the garage door when I've left it open after a certain time. Or if it starts raining outside with a weather API, I can automatically close it as well. So I start just to get creative with these high-level pre-made building blocks that are using your custom data essentially, just to get a feel for what is possible and also what the limitations are. You'll notice when you use Teachable Machine that because it's limited in the fact that you can only have like 100 megabytes of RAM usage in the Chrome web browser per tab, if you have too many images, there is an upper limit to how many images you can train with. And that's when you would want to move to our Node.js infrastructure to train larger data sets, for example, which will in turn result in a better, more robust machine learning model, which you can then use, of course, in the client side. But the training might need to be done in Node.js for that kind of stuff. And that's how you start unraveling the layers. Is okay, well now, I want higher accuracy and better robustness. I need to now learn how to do this in Node.js, for example. And then you start unraveling more of the onion and go deeper down the rabbit hole. But first of all, definitely try Teachable Machine. Second, try to use our pre-made models that are nice, easy to use JavaScript classes. And that gives you a real good flavor for different types of ML that are possible. We've got things that allow you to do object detection, pose estimation, body segmentation. We've got face mesh that allows you to see 468 landmarks of your face all in real time. And with that, you can do a whole bunch of interesting things. In fact, I think Modiface, which is part of the L'Oreal group, used it to do AR makeup try on. And now they can allow you to try on lipsticks and things without even leaving the web browser. And it looks really realistic. We use like 3JS shaders and all this kind of stuff combined with face mesh to then put lipstick on people so they can see what it looks like before they buy it. So you can get really creative just with these pre-made models. In fact, all of the demos that we've spoken about today are using our pre-made TensorFlow.js models that are these easy JavaScript classes. It's actually very rare that you need to roll your own from scratch. Only very few to do that, actually. And you can often find a pre-made solution that you can leverage and repurpose for your creative idea. Then finally, for those who want to go the whole way, there's a great book called Deep Learning with JavaScript that is designed for people who are completely new at machine learning, but familiar with JavaScript, to take their first steps and also go from zero to hero in a, I think, 10-chapter book. It's quite thick, but it literally walks you through beginning to the end. And from that, you can definitely get a very robust knowledge of machine learning as well.
Very nice. Yeah, I think,
I think you're muted, Grant.
That's a great set of information for people getting started. You went through a lot of different terminology and aspects. Do you find that when you're talking to web developers about these models and sort of just bringing up tensors for the first time, do you have a sort of a spiel or how you plan on communicating what those are? Or do people generally follow along? Or do you have like, hey, let me just kind of throw this at you and then here you are? Because I've seen, when people come from web to machine learning, there's a lot of terminology.
Yeah, and even more confusing.
Speaking of which, you said tensors, and I'm not 100% clear on what that is.
There we immediately started doing that. Yeah.
I mean, maybe Gant's actually the guy to explain tensors. I remember trying out his course that he made not too long ago when I first joined the team, and he's got a great course going into what on earth is a tensor. And you essentially realize it's just a multi-dimensional array with some extra functionality layered on top of it. That's all it really is. But understanding how they work and how to manipulate them is extremely important. And Gant's course is great. And get familiar with TensorLand essentially before you start using them for real things.
Oh, thank you. I had no idea if that was, actually out of the students that have spoken to me, quite a few of them have been like, why do I need to know this about it? And then later on they come back and they're like, that's why I needed to know so much about this. Thank you.
Yeah, when you're just starting out, you might hear the word. It's good to be familiar with what it is and what's kind of going on behind the scenes. I think it's always nice to have that kind of fundamentals knowledge just to see what's going on behind the scenes. But you probably won't use it until you start getting your hands a lot more dirtier, so to speak, and going down, making your own models and all that kind of stuff, or tweaking existing ones. And as we said before, 95% of people might not need to do that for a long time because there's so much out there you can just reuse and repurpose. Just like in JavaScript, you might pick an API or a library or whatever it is and just use it out of the box. You're not going to reinvent that every time, right? So same thing happens in machine learning too.
Yeah, let's go from the other side just for a minute here. Let's say somebody listening to this is a machine learning expert, but they are looking to offload the server costs to the client.
Sure.
And so that's why they're interested in TensorFlow.js. What process would you recommend for them? Would you suggest that they train in Node or that they kind of train other ways?
Yeah, that's a good question as well. Honestly, I'd let them choose whatever they're more comfortable with. Now, if they are already an expert in machine learning, there's a good chance they came from Python land. And in that case, we actually have the ability to run Python saved models. And that's just a certain format that you can export. Once you make a model, you can dump that model to a file, and it's called the saved model format. And essentially, you can run that saved model format in Node.js without conversion, which is pretty cool. So you can just then integrate with your web team very easily to then get the reach and scale of the web if you so desire. Now, the second path is to convert that saved model format into JSON format, essentially, which is digestible by the front end. So as you just kind of guessed there, JavaScript runs everywhere. And depending where you're running it, you need to have it in the right format for client side versus everything else. That's the main two differences, client side and everything else. So if you want to run on client side, we've got a command line tool that you can run on a saved model to convert it to the JSON format so that it can be run in the web browser. And not to get too techie here, but essentially, the only caveat with that is command line conversion, which is only applicable to go from Python to JavaScript on the client side. We only support about 200 or so of the TensorFlow operations, and maybe let's say there's 1,000 of them in to start with. So if you're going to do that, you have to make sure that the model you've created is only using the 200 operations that we actually support on the client side. Now, these are popular ones, so hopefully most of the time it does convert. But if it doesn't for some reason, then they'd have to look into rejiggling their model model on the Python side to not use certain operations. And of course, TensorFlow.js is completely open source. If they wanted to, they're welcome to contribute those missing hops. We're only a few people on the team, so it's always great to have extra hands contributing as well. And then, of course, if they want to go full out and write in Node.js from the beginning, that's completely fine too. And there are some advantages to using Node.js over Python in this use case. So when you have a machine learning model, typically, in order to use that model, you've got to change the input data into a form the model can digest, because machine learning can only work with numbers, essentially. So when you've got data coming from a webcam, a microphone, or some table in Excel or whatever it is that is your source, you need to convert that. You've got to do some pre-processing in order to get that into a format that the model can take in as its inputs. Now, if you do that in Node.js land, you can actually see a significant speed boost for that pre and sometimes post-processing afterwards as well. And we've seen with people like Hugging Face, who are quite famous for natural language processing out in the real world, they saw a 2 times performance boost just by switching to Node.js for their pre and post-processing and then digesting the saved model in Node, which is great for doing pretty much nothing other than writing in JavaScript. So completely, if you are a Python expert and you don't know any JavaScript, then it might be fine just to stick to Python. But if you are willing to delve into Node.js, then you might see some performance benefits from that too, which is great. And if you're an existing JS developer, then of course, just start with Node or vanilla.js on the front end.
That's awesome.
Leveling up is important. I spend at least an hour every day learning ways I can improve my business or take a break and listen to a good book. If you're looking to level up, I recommend you start out with the 12-week year as a system to plan out where you want to end up and how to get the results you want. You can get it free by going to audibletrial.com/code. That's audibletrial.com/code.
And well, I tell you, Python's been around for a while, so they have a large set of libraries like image augmentation and adjustments to get there. Do you think that on the Node front or training in Node, we're going to see the same kind of libraries? I guess my question is parity overall. Where do you see, are we going to see Python Node parity? And then also those 200 versus 1,000 functions for client on the JS side. Is there planned parity there? And what are the priorities? Where are we going to see people try to match first?
So honestly, my gut instinct is that JavaScript is actually more powerful for graphics right now, because from day one, it's been designed for the presentation of information on the internet, to share research papers or whatever it was. So JavaScript, HTML, CSS, this stack is amazing at creating charts, at doing 3D graphics in WebGL and all this kind of fun stuff. So I think our charting and graphics libraries are already more mature. Now, the advantage that Python might have right now, which I think will change over time, is that it might have more advanced scientific and mathematical libraries, because a lot of researchers traditionally have used Python. But as machine learning starts to move to JavaScript, and 67% of people use JavaScript according to Stack Overflow of 2019, then we're going to start to see a lot of those kinds of things ported over to JavaScript land as well. And then at that point, you've got parity or better, in my personal opinion. And I personally love JavaScript for prototyping things, because it's just so easy to reuse code across the whole stack: front end, back end, Internet of Things, native mobile, native desktop. It literally runs everywhere. And there's very few languages that can do that without extra plugins and additional effort. So for me, that's the superpower that I love the most, and why I'm a big fan, big JS fanboy.
Good.
Yeah.
So what's the portability to other tools? We've kind of talked about portability between Python and JavaScript, but what about portability to some of the other machine learning tools out there? Can you take your model from one and stick it in the other?
So our team doesn't support conversion to other machine learning formats. However, if you are writing in TensorFlow format, so the saved model format that I spoke about earlier, you can convert that to some intermediate format that then can be digested by other libraries and so on and so forth. So there is kind of like a hacky way to go about it, but there's no official approach as such. But there are formats which convert to other formats and so on and so forth until you get to the thing you want. But it's a little bit hacky. So that's something to bear in mind.
Yeah, in the past, I've used Onyx to try to get there. And I've always been the first person to file an issue sometimes.
Yeah.
So I'm really looking forward to Onyx being fully supported setup. I'll say this, TensorFlow needed TensorFlow.js. If you take a look at the model zoos are just like awesome repos, but for some reason, like the name of art in machine learning is called a model zoo, which is a funny thing. The model zoos for other frameworks have been very attractive, very fun, interesting, exciting. You can almost feel the PyTorch, like, let me play with this kind of draw to it. And then when you look at TensorFlow's models, they feel very industrial, like very valuable, but industrial.
Yeah.
But TensorFlow.js is sort of the antidote to that because, like you said,
middle essentially, right? So
I am super happy to see that. I would love to see more examples in the TensorFlow. I guess TensorFlow doesn't really go with the whole zoo terminology.
Sure.
They have like the models and stuff. But do you kind of see that is TensorFlow.js going to be the beacon to TensorFlow for a lot of people out there? I guess for, because the truth is the demos have been quite exciting. Do you know, is there a new model or demo? Like, is something new coming out that you can kind of tease, or maybe you're not allowed to say it? But
so,
I'd love to know.
You raised a really interesting point there I just want to touch on as well quickly. Like, I'm super excited that I think TensorFlow.js has awoken the creative community, people who are not academics and researchers especially. And we're starting to see, like, just for example, there's one guy in Tokyo, Japan. He's actually a dancer, and he's used TensorFlow.js to make a hip hop video with this cool kind of semi-invisible effect where he's like dancing around and it's tracking him in real time, and it's got this cool kind of effect going on. And it just shows that machine learning can now be used by anyone. And I'm super excited to see how creatives, musicians, artists, all these kind of folk are going to embrace it and use it in ways that researchers and traditional engineers will never have dreamt up. And I think that will be the bandwagon that gets all this started and could make JS, a big player in the ML space. Right now, it's more of a few people experimenting, but as more JS developers take their first steps and realize they can combine it with their traditional creative mind that I know that they have, we're going to see it being used for many interesting things. And I'm super excited to see where that goes, actually.
So one thing that I'm wondering about with this, because we've talked about a lot of the kind of the fun things you can explore, some of the areas where you can dive in and see what the possibilities are and things like that. My question is, if I wanted to go to my boss, right, and say, boss, I want to do some machine learning. I think it would benefit the company. I mean, what's the sales pitch there? What kinds of things can I tell them that we are going to get out of it? Because, I hear people saying we're using machine learning and they kind of buzzword it out, but nobody actually explains how it's beneficial to those companies beyond just kind of having people go, oh, yeah, that's cool, man.
And on that note, not every solution should be done using machine learning as well. But sometimes where you want to use plain old computer science, and machine learning is not the answer for everything.
I don't want everybody to know that I disagree with Jason here. I coded a FizzBuzz model because what you need to do is FizzBuzz is way too hard to write an actual just computer science code. You need a ridiculous machine learning AI model to solve it.
Yeah, Modulo is way too advanced for me.
I'd love to be in one of your interviews, Grant. Like they ask you this problem, and like maybe you get the answer wrong the first time, but you just keep on going until you get it right, and then hired because machine learning. You just keep on throwing out answers there until it's correct.
You've proven yourself as a data scientist. Yeah.
Well, if you take this number and you move it into the other register, and then
anyway. I say now, but yes. What was the question again?
The convince your boss, I think.
Oh, that's right. Yes. So first of all, look for something that maybe is a pain point in your current workflows. So let's just take a very simple use case, which could affect many industries. It's not industry specific, but you've got a contact form on your website, right? And that form can go to the sales team, it can go to the engineering team, it can go to all these different teams within your organization, depending on the query that's written in that big chunk of text. Now, in the old days, you would be essentially reading that. Someone would read that and then decide who to forward it to then deal with it. And that's a waste of human time. But that person can be doing much more productive things. Using natural language processing, once you've got a few thousand examples of this, you can actually then figure out if a chunk of text is probably related to a salesperson or probably related to a technical question and so on and so forth. And you can automatically have it route to the team you think is probably the one. Now, if it gets it wrong, that's not the end of the world because the team will just then reroute it just like anyone would have done in the first place. But 90% of the time, it will go to the right team off the bat. And this is a great example of how you can optimize and be more efficient. And if you can do that, you're saving money. And as a business, that's a good thing. Especially if you're a startup, you need to save every penny and use that in the best way that you can. And I think every industry has the chance to be influenced by machine learning in some capacity. And over the next decade, we're going to start to see that happen. And the companies that do embrace it and manage to automate things that otherwise would have needed a human will see the efficiencies and obviously have an advantage over their competitors. So that's where I see it standing right now and how to choose a problem.
Yeah, I think what you just said outlines sort of the value proposition for machine learning in a company. But the issue is okay, well, how long is it going to take to pay off, and how much work are we going to have to put in, right?
Exactly.
I mean, one thing that I found in my business is, I trained somebody else who I value their time at less than mine, meaning I'm paying them less than I need to be paid in order to make it worth it, right? And eventually, after I train them and they do it 5, 6, 7, 8, 10 times, right, I'm starting to make that money back because I'm doing more profitable activities for my business. So the issue here, though, is that to train this system, you actually have to spend engineering time and you have to validate the results because, it's a different animal from training a human. Not that I'm saying humans are anyway. So, but you get the idea, right? So, yeah, how much work is it going to be, and how long is it going to take to pay off is another question that I think managers are going to ask.
So there's no general answer here. Some problems are well solved in the realm of machine learning, like object detection using the webcam, or even some of this stuff, like I mentioned, like the natural language processing to determine if a piece of text belongs to some corpus or a different corpus. That is actually fairly easy to. There's plenty of examples out there that within, an hour, even if you're fairly new, you can take some existing stuff and just repurpose it to work on your data set. The key thing is the data, actually. The hardest thing you will have is finding enough data that is useful for the use case that you're trying to do. That's actually the bigger problem that most people have. The machine learning side is actually, there's a lot of stuff out there you can use in a very easy manner these days. The problem is getting the data for your specific niche use case. So if I'm a farmer trying to recognize apples and oranges, then I need data on apples and oranges with their maybe weights and colors to be able to identify them later on. And maybe that data set doesn't exist yet. So I've got to go and gather that data myself. So the biggest problem I see when people are trying to do this is that they haven't been recording that data in the first place. It's not been recorded for some reason. So then they've got to spend some time recording it so that they have stuff to use in that machine learning training, essentially.
Well, I wanted to throw in there as well. There's this ominous, ever rolling forward sort of explanation of saying like, I can do this. How long would it take for me to do this on a computer? I could do it on paper, and then now everything's on computers and anybody who's doing anything on paper. So I'll say that there's always this extra motivation I want to toss in there. I think that pretty much soon enough, you don't want to wait. You don't want to be the last adopter of AI, right? The same way you didn't want to be the last person to go to web or the last person to go to mobile. So you always have to factor in whether or not the time's worth it. There's a growth factor because I've never seen something accelerate like this. So as my little tidbit, I'll toss on top of there. Of course, we all don't want to do something that takes a ridiculous amount of time, but also you don't want to be the holdout.
And obviously,
you don't
if you're
want to
a
end up
business
behind
that
people.
if you're a business that is maybe not so techy, maybe you don't have any engineers right now, then yes, that is a big investment to start jumping on the ML bandwagon. But if you are a business that's already got some web devs, like JS devs or something, then starting to use machine learning is not as big of a change to using a different API or something like this. So in that respect, it might not be as scary as one might think at the beginning, essentially, and it might be an easier transition as long as the data is there. But yeah, of course, people should definitely record like before and after. the efficiencies and the costs and all this kind of stuff. And, as long as it's going up and to the right on the graph in terms of, well, I guess down actually, you want the cost to go down, wrong way around. But as long as those things are going down and the customer satisfaction is going up, then ML could be the good thing to use. But if you find it's not, then of course, continue using your existing process that's actually working out better, or use other techniques.
Makes sense. One other thing that kind of feels a little bit daunting to me, and you brought it up, was the real trick is getting enough data in there to actually train it properly, right? And we've seen issues with this where they were categorizing photographs and they didn't put enough of the right data in there. And so it categorized people with certain facial features as certain kinds of animals, or where it categorized, like there was a picture of Auschwitz and it categorized it as a playground, and it's just like, it's like so far beyond, to our sensibilities, it's not even funny that it's wrong, so how do you make sure that your data sets are sufficient to not make those kinds of mistakes? Because if it categorizes me as a woman, I'm probably going to laugh. But if it categorizes, some of these other things, those other examples, it's like that's kind of offensive. But it's just the algorithm, right? It's not intentional. But you don't want to go through that.
Yeah, totally. And this definitely comes down to having good training data that's unbiased. Let's say you're making a speech recognition system, okay, and you are based in America and you're learning to recognize English. Now you've sampled it on all your friends and family and everyone in your state and even maybe other states. And then along comes a British guy like me and I break your system because you had no British folk talking in English. And that accent that I have is just not recognized. And this was definitely a problem with speech recognition earlier in the days. And now they're much more robust. They've got samples of people talking in like British English, Canadian English, maybe English with accents if you're like Indian or something. So there's now much more robust training data that can account for these differences. But you do need to find that. And these biases are not always conscious either. Like people were not trying to exclude like British speaking folk when they made speech recognition, right? It just didn't cross their minds that to the ML model, it would have difficulty in that kind of transferability to pick up the nuances in how things are pronounced. But it does actually matter. And you have to be very careful there. And the best way to do your due diligence is to get a wide variety of people to test it with in a private testing environment before you go live, from different parts of the world, different regions, different backgrounds, all this kind of stuff, just to kind of make sure that you've done your best due diligence, that it does work in all these situations. And this is a really hard problem because we're just talking about humans here, but what about operating systems and other things, other environmental changes that are not like to do with humans as well? All of these things could affect the quality of the ML model. And a good example of that is a model that was trained on digital SLR, high definition footage from a pro recording studio versus me trying to use it on my webcam once it's released. And that grainy webcam data is completely different bunch of numbers as far as the computer is concerned versus the production quality, beautiful, high definition pixels. So you need to make sure you have data from all those different areas if you're going to have a really truly robust model. So it's very hard to do right.
Well, I'll jump in and just say that certain people have to bear that cross harder than others. So for instance, we were talking a moment ago about, is my garage door open or is my garage door closed? In that sense, what I just want to kind of like say is like, it's a new way of thinking. I'll say when people built apps, they didn't think about the effects that these apps had. But then, we have web and mobile. We have to think about accessibility. We have to think about, QA knows to ask these questions. This is all new, and it's kind of going through the more things change, the more they stay the same. Because if you have something that it's trying to see whether your garage door is open or closed, then it can suffer from that problem you mentioned earlier, Jason, that it's a blue deck of playing cards, it's a red deck of playing cards. It's okay, because this isn't identifying whether or not a person has cancer. The stakes are different.
Context is definitely a big thing here. Like if you're
and I only care about one garage door.
If you only care about that one garage door and you're not going to deploy this to the rest of the world, then sure, for your prototype, you might not need to have every garage door in the world in that training data, right? And that could be good enough for certain projects. But if it has the potential to affect the life or be offensive or something like this, then extra diligence is definitely required. But it depends on the situation. And just one thing related to that is with machine learning, explainability is sometimes an issue as to why people don't use machine learning. So if I use regular computer science to, let's say, recognize Gantt space on this video call, I could use, there's two circles there. There's like a rectangle, which is his glasses, and some kind of grey rectangle at the bottom for his nice goatee and beard. And and basically, you can put together a robust computer vision model using plain old computer science that can explain exactly how it works. It's looking for two circles, some rectangles, and blah, 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 certain colors, and so on. Now, if I train a machine learning model to recognize Gantt, it might actually perform better and be more robust, but I cannot tell you exactly how it came to that conclusion. At least with current technology, that's harder to do. You have all this bunch of mathematics that magically works out with the right answer. And as you dive deeper into machine learning, you can see why that works, but explaining it truly to another human is very, very tricky. And that's why we see some industries, even like medical, very slow to adopt some of the machine learning practices because they want to be sure that it's not just a fluke and it's got enough unbiased training data that will work on all patients and not just the data set they use, and so on and so forth. So in those cases, one must be much more diligent.
Yeah, well said. And I think that, each of these problems for companies sort of pitching it, there's different rooms for error. When we say medical, we're talking mission critical. Code is different. Mission critical code is still written like in COBOL. like these airplanes are written in these sort of functionally strict programming languages, and JavaScript, is dynamic. So the truth is, be an adult and be friendly with that data. I mean, I'm sort of augmenting what you're saying here is that, it's important, but you have to identify what the project is and whose lives you're going to affect. And that's software. That's not just machine learning. That's not something somebody could say the machine messed up. As a matter of fact, companies who are saying that and MIT trying to say that is like, no, that's not it. It's no longer an acceptable answer.
Yeah.
Well, the other thing is, and this is something I'm just going to put out there for our audience, is that a lot of these conversations are happening out there already.
Yeah.
Some of these mistakes have already been made. I mean, I brought up two examples that were, offensive, right? Because, if I hadn't been aware of that stuff and I was putting together a model on recognizing people speaking, I'd have gone around and recorded all my buddies and come back here and we would have the Midwestern Utah accent and, that'd be it, right? But because I've paid attention and been part of the conversations and listened to what people have run into. And so go out there and just see what people are concerned with, see where these things have had these mistakes made where the models weren't robust enough. And then you can go in and say, okay, what data do I need to add to this in order to avoid these issues?
Yeah. And one more piece I just kind of want to say here, Jason, part of the reason I really love what you're doing with TensorFlow.js is because it goes out to the edge and it goes out to people. It's probably one of the best willing data capturing systems out there. If your goal was to make the most robust garage door system, how hard is it to just go ahead and pull up a web page on your phone and help feed that kind of data? I mean, normally data science is a lot harder than webs. And I think that's really cool because what we're seeing here with TensorFlow.js going to JavaScript like it is, that's where a lot of UI is. And